All right, well, thanks everyone for being here today. It's great that we've got such a fantastic turnout. Um, as Kelly said, I'm helping lead the next phase of technology and platform development at Gloss. But it's not just serving Gloss, it's really serving the public and it's serving the whole Great Lakes region. That's the entire goal of this. And what excites us, I think, most about this is that we feel like we have a really good opportunity in front of us, not because of technology development and availability and some of these things I'm going to talk about, but the community that's really rallying around the Great Lakes right now, and with the number of people that are interested by attending this meeting today. And we had a similar meeting in Toronto a few months ago with a similar type of interest and level of participation. So binational, centered around community, centered around technology as well. And like I said, gives us a real opportunity to do something amazing that surpasses the vision and the goals of Gloss. As Kelly said, yes, we're a relatively small nonprofit organization, but we've got a massive vision and big ideas. So that's great. One of the things, I'm just curious, have you heard of the term data lake? And you may have. It's generally accepted as it's a large repository of structured and unstructured data for processing, analysis, and algorithms that other people can access. It's a lot of data together, and we don't have a data lake. That's not what we have here. What we have, and this is just a photo. It's not a real data lake. This is actually the view from the offices of Gloss in Ann Arbor. What we actually have are data islands, and data islands they're disconnected silos or data warehouses, whatever term you want to call it, but it's disparate data scattered among different organizations, different agencies, different collections of data. What that leads to is something called data dispersion. And data dispersion is what we have in the Great Lakes. And we're not alone in this, but we certainly have this in the Great Lakes. It's not a bad thing that everyone's collecting data. In fact, it's great that we've got lots of people collecting data. But it limits our ability to collect, to aggregate and process, analyze, and come up with results from this aggregate of data when the data is dispersed in different silos. So one of the goals that we have is to help bring this together. Not necessarily all of the data. Gloss is not coming for your data or any other organization's data. We might be coming for your metadata, because what we want to do, the ultimate goal here, is to make data more discoverable, make it more accessible, and make the results of that and make the information from that available. So some of the reasons, some of the, trends, that are allowing us to do this, or making it more easy for us to do this. Well, the first one is the sheer number of devices in the region is growing. We have, literally the potential to deploy hundreds, if not thousands, of devices. We're moving away from a paradigm where devices cost $75,000, $100,000, or $50,000, whatever the cost is, to on the order of $500 or $5,000. We're working with a company where you can buy their products just off their website, add it to your shopping buggy, click, go, put your credit card in, how many would you like, and it gets delivered to your door in 2 days. I mean, that's the kind of model that we have the potential in front of us here to really change the way data is collected and shared within the Great Lakes. Collecting data is only one piece of it. So having access to these amazing devices at low cost is great, but the ease of use has to go along with it. And that's the other thing that's changing. That's another big trend that we're seeing, not just in our segment, not just in our community, but in other communities where it's super easy. I mean, a backyard drone is probably the greatest example of this. 10 years ago, where these were still called AUVs, and not drones as people tend to call them now, it was really complicated. It was really limited to experts and hobbyists. Now you can just buy one on Amazon, right? Comes with an app on your smartphone, you throw it in the air, and away you go. it's not out of the realm of possibilities to think that you couldn't just buy a little tiny buoy or some device that gets mounted on your raft or your dock or your personal watercraft or whatever it is, and you can be collecting data in the Great Lakes super easily. Another big trend that's happening is the cost. I already mentioned this. The cost is coming down. So across the board, we're able to reduce the cost of all of these. You can get a lot more devices collecting data in the Great Lakes. And then the biggest trend probably that we're going to see in the next couple of years still to come is something called smart devices. And that's devices that can not only talk to each other, but can talk to our smartphones, our systems a whole lot easier. They can do processing by themselves to convert that data in real time or near real time and send the results only, especially devices that are capturing large information, whether it's audio or video. Maybe we're only interested in the relevant and contextual portions of that data. Maybe it's smaller data sets that are collected and it can send the full data stream. That's awesome too. But we're definitely moving to a trend of smart devices. And I'm not, I mean, you can think of smart devices like the refrigerator in your home telling you that you've run out of milk and it's time to go to the store, which we're not allowed to get more milk. But if we could, that's what you've got, a smart device in your home. Now, transpose that to smart devices in the water, collecting data, and that's going to be phenomenal for what we're trying to do here in the Great Lakes. All of this is great, and it's awesome, and I've been an advocate for many, many years of the more devices that we have collecting the more data, the better off we'll be. However, it does lead to a problem, and this problem is that the gap between the amount of data that we have available to us versus our human capacity for processing and crunching all of that data, that gap is growing. So this actually is going to force us into another paradigm of automated processing, augmented intelligence, artificial intelligence, machine learning, a lot of these technologies that are coming up in other vectors of our lives, but we're not really taking advantage of them yet in the Great Lakes area for our traditional applications as it relates to model and observation technology. Not all of this once again just points to opportunities for us. So when we look at some of the things that are happening outside of, let's say, the marine community, we're looking at things, internet. I don't know if you've heard of the fourth industrial revolution, but the fourth industrial revolution is following on like these massive, I guess, times in our industrial lives, I guess, right? But this one, the Industrial Revolution 4.0, what we're in right now, this is automated processing, machine learning, bringing together technology so that they can communicate from technology to technology without humans involved. Now, a subset of that is something called Internet 4.0. We're currently in Internet 3.0, but Internet 4.0 is where we move from a paradigm where we access internet on demand to a paradigm where the internet is around us all of the time. It becomes ubiquitous, not just for us, but for our devices as well. So bringing these two together, and when you combine that with technologies like cloud, edge, fog, machine learning, artificial intelligence, all this amazing stuff, you've got a recipe that's ripe for amazing development in the Great Lakes region. So I'll just give you a couple of examples here. Imagine a scenario where we have hundreds of devices working together real time to collect and process data in the Great Lakes about, let's say, harmful algae blooms, right? Which I think Mark already mentioned, it is, plagues us every summer, especially in Lake Erie. And there's this lag of the amount of data that we can collect and then how we can turn that into information that's meaningful. So that's just one scenario. And then not only is it collecting and processing this data, but it's sending the results to you in real time. So here you are on a Sunday morning and you're reading the news or you're checking up on what's going on with COVID-19, and boom, you get an alert on your smartphone that says, hey, because you're a water treatment manager, I forgot to mention that, the toxicity levels in Lake Erie or in an area that you're interested in have exceeded some acceptable threshold, and you need to put the necessary processes in place to make the water safe and secure for your citizens. So this is a direct benefit to humans that are consuming water, right? Because of additional sensors and smart sensors that we've got in the Great Lakes. And in this scenario here, we've got a person who's having a cigarette while they're doing it. Okay, so here's another scenario where we've got sensors that are, this is the Soo Locks, right? And there's potentially hundreds of devices that are measuring water pressure, infrastructure, integrity on the whole ecosystem around the Soo Locks here that are holding back Lake Superior, right? And making sure that the rest of the Great Lakes don't get flooded by this water being held back. So there's just another light example of sensors that can work together to tell us information about what's happening in a marine environment. Here's one of these examples I gave you. This is from a company called So Far Oceans. These people make a device, selling it just off their website. It's $5,000, relatively inexpensive. And it's measuring many of the same properties that a larger buoy does. And I'm not discounting the value of larger buoys. It's just, this is presenting another option for people to collect data that's relatively easy to access, relatively low cost, and can achieve some of the similar results. And same deal, this is able to transmit real-time information back to our systems, not just humans, but back to our systems to process the data and get it in the hands of people who need it fast. Here's some subsurface floating robotics technology. This is in tandem with swarm technology, another opportunity you may be familiar with. This is where devices can work together to communicate results. So sometimes just understanding what's going on at one location isn't enough, but when you combine that with hundreds or dozens of devices in the same region, it can paint you a picture of what's happening for that body of water on a slightly larger scale. All of these technologies working together, working independently, are just great technologies. It's not until they actually work together and have some societal benefit that they become smart. So by themselves, awesome, maybe we'll call them smart, but when you put it into the context of an ecosystem working together, that's really what drives the technology side of the Smart Great Lakes Initiative. So Kelly mentioned this already. We're working to organize a technology ecosystem to help us better understand, monitor the environmental conditions in the Great Lakes so that we can get better information faster and more timely and in context. So what are we doing about it to support that? Well, we're building a technology platform. And it's meant to support smart devices. It's meant to drive information and ultimately actionable intelligence. And that previous example where Brenda was smoking a cigarette on a Sunday morning and she got that alert, I mean, it's really that actionable intelligence that would allow her to make a change in her downstream systems based on information that she got that's going to have some benefit to the people that are, in that case, consuming drinking water. So our goal here is to help close that gap between lake data and ultimately knowledge. And so if you think about that graphic I showed earlier, where we had tons of data coming in, or the idea of tons of data coming in and the inability of humans to process it all. So if we can provide a platform to make that a lot easier and close that gap, that's gonna help. Obviously, that's the goal here. That's one of the goals. So we're building a new platform. It's called Seagull. And there's a few major tenets we're going for this in this new platform. Well, for one, it's got to be centered. It's an information. It's a data and information-centric paradigm. So this whole notion of converting data from data into actionable intelligence, but through the conversion of information. Couple of hard lines for us. It's got to have a great user experience. It's got to be easy to use. Like I said, it's got to be driven by information. But then really on the back end, and this is what we're focusing on, this is what we've started on, we want to have this pipeline of observation data, model data, and IoT or streaming data that's coming in from devices through a tunneling platform to make it easy to access. So that the user experience or the user interface may not necessarily be through Gloss. It may be through an app that you develop on your own, or you work with some other technology partner, and you develop an app that sits on top of or takes advantage of the Seagull platform behind the scenes. So a very API driven platform, both on the ingestion side of data coming in to Seagull, but also on the output side of data going out. Abstract, this is what I call my architecture diagram, right? Half marketing, half architecture. So some major pillars here, and if you're looking at it, we're going from left to right. So we've got a variety of input devices on the left. We've got maybe vessels, smart devices, other systems that are in place, robotics, other systems that could feed into the GLOS platform, subsurface systems that feed this content in. A bunch of machinations happen, we process the data, or not. Maybe we just store it as raw data, maybe we do some initial post-processing. We make that available through a variety of interfaces, and these could be APIs, like as I mentioned, to allow enabling technologies or apps and services to consume that data and then do something else with it, or push it out as additional information or additional web or map or feature services. But ultimately, we do want to make that data available for consumption. So maybe it's consumption through services, maybe it's through download. In fact, if you're doing additional analysis or research on it, awesome. Whatever your application is, we want to make it available to you. So we did do a prototype. We feel like we're fairly confident, I guess, that yes, we can make this work. In 2019, we ran a prototype. It was relatively lightweight. The whole goal of that prototype was, can we put some devices in the water? Can we take their data through streaming or pseudo streaming? Because in the end, we had to fake it a little bit to make it, and bring that data into an automated platform in the cloud, and in turn, automatically push that data out to smartphones so people could be notified of some thresholds and alerts that may need to happen. Yes, that worked. Now we took those we took those results and turned them into requirements. We went through a process with a variety of different partners and technology companies to come up with a requirements document. We're just in the process now. We're very close to awarding this platform development to one of our technology partners. And we're going to ultimately have a goal here of serving thousands of users with hundreds or thousands of devices in a platform to convert data to information in the Great Lakes. Our whole goal here is to have a connected technology ecosystem to support the Smart Great Lakes Initiative. That is the goal of the platform. And we're looking forward, really, for ideas, partners, whether they're technology partners or ideas, or people who are bringing concept and policy and other phenomenal opportunity, really, to the table. That's where we are today.